So today I'll be giving a crash course presentation on FaceNet. And for reference, FaceNet is a document and paper written by the University of Cornwall, and they pretty much made a very accurate system to identify faces within facial recognition. And the accuracy ranges from 95% to 99%, and those are pretty high values. So to quickly get through the main topics here, there are AI theory, which has artificial neural networks, AI-related software Python, AI-related platform, which is Google's TensorFlow, and the domain that it might be applicable for is Homeland Security, and the application is criminal facial recognition. So we will first be going in reverse to kind of go from a very, very high-level applicable situation to the nitty-gritty details of it. So, to begin with, facial recognition. How does one even begin to recognize faces in images? So, most people know that images are made up of pixels, and each pixel has, if you take out the color from it, it has a dark value and a light value, and if you can detect the differences between each one, and see here in the middle picture, you will see that the color transitions from a lighter to a darker and has an arrow to it. That represents the histogram of orientated gradients, where you map out a system of gradients. And from there, you can kind of see on the right-hand side that the mapping of the eyes, the mouth, nose, and kind of the overall shape of the head and stuff like that represents something related to a face. So getting into the more specifics of it, well, once we have those basic parts mapped out, we want to say look for the mouth, nose, and eyes. Well, that creates a new kind of neural network that we'll have to train it. But to kind of back up a step, we want to look for the outline of the whole system. So looking for, say, specifically the face outline and the nose and the eyes, you can train the system to kind of identify these based off of the different directions the person may be looking at the picture, because to the computer, it may look like a completely different thing. And so using affine transformations to once identify the face, rotate it, and things like that, the algorithm for figuring out the whole situation in terms of the face outlines and the nose is called face landmark estimation. I won't be going into depth at all into that, because that's a whole nother topic that I don't quite have time for. But once you establish kind of the outlines of the face, you can match it with your labeled faces with how accurate, say, the faces and the gradients are to the specific people that you're looking for. So in my example here, based off of David Sandberg's system, he uses Google's TensorFlow, which is an open source library, which ends up using neural networks to quickly solve the massive amount of data that it needs to go through. And the programming language he uses is called Python, and it's mostly based off of Google's TensorFlow. So that's kind of allows users to quickly and easily implement the system with a high level language that holds the features and support. And lastly, the quickly narrowed down version of the artificial versus convolutional neural networks. So convolutional neural networks are a subcategory of neural network. Most people know that a neural network contains a lot of, say, for instance, a lot of inputs and weights that apply to making a decision, and the more closer things are to it, the closer it is to what the end product is. A convolutional neural network is kind of a reinforcement of that, but it subcategorizes portions of the say, for instance, image that it's calculating, and will identify certain parts like filters with, say, taking an image, reducing it down to a face, and then reducing that further down into other layers such as eyes and mouths, and then you're able to calculate, say, an individual base face based off of the distance between the eyes and the mouth, and the ears and things like that. So that way you can transition from high level features of, okay, how can we quickly find the basic features of a person, and then transition that down into the specifics so that you're not looking through every single individual face. And from there, that's pretty much it. Thank you.